Hello. Hello.
Good morning.
How are you?
Good. How are you?
Fine, thank you.
There we go. How you doing, Professor?
Okay, Alex, how are you?
I'm good, thanks.
Good. Lucy's up early. All right. Somebody else there? Who else is there? Andrew's here. All right. What do you want to do today? You want to play the quarantine game?
Why not?
Here's how the quarantine game works. You mute yourself and you sit there and stare at the monitor and do nothing. It's really fun. All right. So, anybody have any news to share? Anything interesting happening out there in the world?
Not really.
No.
I haven't left my house in a bit. That's pretty interesting.
Wow, that's nice. All right. So we've covered that. So my plan, as I've done in the past, is I've given you an assignment, and happy to talk about the assignment or to take questions, or you can, excuse me, you could work on it while we're sitting here or not. You already get full credit for attendance. And so I'll be emailing you each a gold star to put on your forehead to indicate that you attended class today. You don't have to put it on your forehead. You can put it anywhere you want, I suppose. So what would you like to do? Do you want me to talk about anything? Do you want to complain about anything?
Professor, I have a question. So you started the lab saying this case study is designed to familiarize you with estimation techniques for discrete choice models and limited dependent variable models. I'm not sure, when I went back to my notes, I only found like, we did like binary dependent variable, just that was the name we had like at the beginning when we started talking about all these, or the latent, but not discrete. I'm not sure. Is it the same thing or is it?
So discrete choice models.
Excuse me?
So discrete choice models encompass a bunch of things. We've only looked at one thing, which is models where the dependent variable has two possible values.
Okay.
Okay.
So, and this
and
is
so for
discrete.
us, they're binary. It's also possible to do.
Oh, there you go.
Back.
Hello.
All right. So, am I back?
Yes.
Okay. Sorry about that. So discrete choice models means models where the dependent variable has a discrete number of possible outcomes. We've looked at models with two possible outcomes, 0 and 1, but you could also have, you could do things called ordered probit or logit, where the dependent variable takes on multiple values in a particular order, or you could do multinomial logit, where the dependent variable has more than two values. And those things are more complicated, but those are all discrete dependent variable models. And Tobit is an example of a limited dependent variable. Right, and again, that also comes in. There are other versions of limited dependent variable models. So I'm not asking you to do things we haven't done. I'm just trying to expand your vocabulary and give you ways to impress other people. Okay.
Is it me or Professor's going in?
No, he's going in and out.
Yeah, I think
Yes.
it's me.
Okay. So I got that discrete is just like binary, where it can be like the dependent variable can take like two values or maybe more, but
Right.
we're only interested in two here.
Right.
And then the limited is like Tobit, so it's the latent.
Right.
Okay, thank you.
Yep.
I know this isn't what we're connected or what we're doing, but how would you get an outcome between 0 and 1? Rather than having it being discrete like 0 and 1, but like a probabilistic outcome.
So suppose what you had, your dependent variable was, suppose you have two candidates for president, and everybody has two choices, Democrat or other. And that's a joke, but not a funny joke, just a joke, And so, so every individual then has two choices. You're either voting 0 or 1, but if what you're doing is looking at how each state votes, you're going to get a proportion for each state, and it's going to be the proportion of ones. And so that's a variable that varies between 0 and 1, but what you observe is not actually zeros and ones. And you can use OLS on that, or actually there's some other tricks you can do to, and the problem with OLS is that it, as always, gives you the possibility of a predicted value greater than 1 or less than 0.
Yeah.
And so one thing you can do is to take, if you have a proportion for a dependent variable, you can take the log of the odds ratio.
Okay.
as your dependent variable. And you might ask, what the hell is the log of the odds ratio? Right?
That was my next question.
Right. So I'll show you what the log of the odds ratio is. I'm going to bring up a different data set, which actually has this issue in it. All right. So you see my status screen, yes?
Mhm.
This is, so Mary Tercy is doing a senior thesis, and this is some of the data that she's using. And the dependent variable she's looking at is whether people take paid parental leave. And this is her dependent variable. And so for each individual, the dependent variable is a 0 or a 1. But what she's done is to take the average for different groups within states. And so it becomes a proportion. And so if I give you a summary of this variable. So it goes from 0 to 1, but on average, it's a very small value. So the odds ratio is the probability that it's a 1 divided by the probability that it's not 1. And so the odds ratio is probability that y equals 1 divided by 1 minus the probability that y equals 1. That's the odds ratio. And then you turn that into the log of the odds ratio, oops. And you can use that as a dependent variable. And it turns out that the log of the odds ratio looks like a cumulative distribution. It has that S shape. It doesn't go above 1 or below 0. And
Is the point of taking the log of the odds ratio just to make sure it's bounded in that region?
yes,
Okay.
yeah. The difficulty with using the log of the odds ratio is that it's much more difficult to interpret exactly what you found.
Okay.
But it gives you a regression line which doesn't go outside the bounds you're hoping. Right. All right, I feel like I'm 2 for 2 here. What else you got? Do you have other questions? I mean, Lucy got up really early for this, and I feel bad that We're not giving our
No, it's
money's
okay.
worth.
I needed to start my day.
Okay.
Otherwise, I have no strict time that I need to get up and start functioning. So
That's
this
kind
is
of how
good.
the world works right now. Yeah.
It's true.
Yeah. Actually, it feels like the world is really split between people who don't have to get up at any particular time and people who do.
I actually had a question about, I mean, maybe you covered this before, but I was looking at the assignment sheet and it says due date, yes,
Yeah.
but
Yeah, I agree that there should be a due date.
but was just wondering what the time frame you were thinking.
Yeah,
that
it's
would be.
due tomorrow.
Unreal.
um, when do you want it to be due? I'm not afraid of democracy. Tell me what you'd like.
It depends how much we have to do afterwards.
What's that?
I feel like it depends how much we have to do afterwards.
Oh. Yeah, I know. It's
Wednesday.
a little bit awkward that way.
Mhm.
So I'm happy to have this due sometime next week. And if you want to do more after that, you can. Or like I said, I'm not afraid of democracy. And so
Can I speak of the democracy? So,
can I stop you?
No.
I didn't think so.
So, I speak for myself, but next week is pretty crazy, and you might know a little bit. I mean, I have my thesis due, an exam, 3 homework. It's bad. The presentation for the thesis. So
What else do you have to do? I have a dog to take care of.
I have the dog.
Okay.
But literally, I'm just doing home. No, I have more than 3 homework because I have homework every Monday, Wednesday, Friday, plus Tuesday, plus 3 on Monday. So it's bad. Now, this was my opinion. Do you care if we have it due like the week of the 28th, like that week? But then if you want to give us another assignment, another lab on things that we're going to do afterwards, we can maybe turn it in during final weeks. That's my take.
Do I
on
care?
everyone? Like, would it be different from you? In the end, we don't have a final, so.
Right.
Because we are gonna do we're gonna do the other, another topic after this, right?
There's another topic on the syllabus after this.
Yeah, so I'm thinking that if we do this all the way through first, then, you know, we can have another lab if you want. That was my idea. I don't know.
Okay. Anybody else want to weigh in with their view on how this would work if the world was perfect?
I think we could see how we do like on our timeline with this lab and then decide. We don't have to decide right now, right?
Okay.
If that suits people.
Yeah, I mean, I just
Well,
have, yeah, like a
Yeah,
lot
I-
of things piling up next
Yeah,
week and the week after. So I
Then we
think
could,
just knowing if this was like sooner and then we had another assignment afterwards would help me plan for like the end and
So,
finals.
so here's my question for you. Do you want another assignment after this one?
Well,
Maybe optional.
Yeah, it'd be nice. I mean, I'm fine with that, but
Yeah.
like if we have to have one next week, one the week afterwards, that would be a lot. Like at least for what I have to do. But if we have another one, do you like, I don't know, the finals? I think that'd be fine. I think for
Okay.
me, I don't know about the other.
So if this is due on the, say this was due on Monday, the 27th,
Mhm.
how does that grab you? What do you think?
Monday the 27th.
Yeah, what do you think of that?
That's fine.
Anyone want to object?
I mean, I have so much to do before and after that. If I move it, doesn't really matter.
Is there a date before June 1st that would make you happy?
June 1st?
Maybe
Yeah.
like May 15 or something.
Well, how about this? Right now, let's say the 27th. That's a Monday.
Mhm.
And as that date approaches, if it seems like that's problematical, we'll adjust it. I'm really happy not to make your life miserable. More miserable than it already is. Okay?
Thanks.
Yeah, thanks.
And what I would suggest then is, if you'd like, let me just look at my calendar again. How about this? Today and Friday are for working on this lab. Okay? Next week, I'll spend Wednesday and Friday talking about treatment effect models. This lab will be due on the 27th. Last day of class is the 29th. And depending on where we are on the 29th, I'll either leave you with something to do with treatment models, or we can all join hands electronically and sing Kumbaya. Okay. Is that
Sounds good.
That
okay?
sounds good.
All right.
Mhm.
Yeah, like it.
Okay. I do want to give you time to do this, because this one I think is actually kind of, I mean, there's a lot of data there, and it's gonna take you a little while to figure out how to do this particular one. But I think it's worth doing. And I'm happy to call it quits before it's too late. Okay. Do you have other questions, things you want to talk about? Comments? Amusing anecdotes? Andrew?
Yeah, I'm not sure if you mentioned this before. Like, what is like the main like distinction between probate and logit? I know like between like economists and sociologists, like that's one, but what's the other like distinct feature of like the both effects?
So the question is how the error term is distributed. And in probate, it's distributed as a normal distribution. And in logit, it's distributed as a logistic distribution, which has pretty much the same shape, but it's slightly different. Logistic or logit models are probably a little bit easier to turn into something that you can interpret. And probate takes a little bit more work. But I mean, really, I don't know why why one has not taken over. And it does seem to be like discipline by discipline. And economists almost always reflexively turn to Probit, and sociologists turn to Logit. And so it's sort of a class distinction. And I prefer not to state on this recorded class exactly which class is the higher class.
And also, I was looking at like the question one where you say use a utility maximization framework to make your main points. What do you mean by utility maximization?
So these are models of people making choices. And because we're economists, we think about people making choices in ways that are most beneficial to them. And so when we create a model of how the choice is made, we think about the various options, and we assume that people are going to make the choice that gives them higher utility. Right? I think I went through, when I explained particularly the Tobit model, I set that up as a utility maximization problem. But you could do that with Logit and Probit as well. Right. I mean, if you just say that people have a choice, A or B, which do they choose? And why do they choose it? You don't have to have had 3 semesters of micro to suggest that maybe they choose the one that gives them the most utility. Probably half a semester would do. Okay. Anything else? I want to make sure you get your money's worth. All right. Well, if you have any questions, I mean, I hope you will get to work on this. If you have any questions as you go, please let me know. I guess that's it. Lucy, is breakfast next or what's up?
Coffee first, and then we'll go from there.
All right. Sounds good. So let me, I'll ask you one more question. Would you like to do this again on Friday, or should I just wait to hear from you?
I say let's do it Friday.
What's that?
I say let's do it Friday.
All right.
Friday sounds good.
All right. So maybe on Friday you'll have more questions.
More questions.
Yes,
Okay.
sir. I have a little question, but I think I can figure it
You've
out. But
already
the only
asked
thing
the
is,
question.
I know, but I use my second bonus for Friday. We say that when we take the CDF, it's distributed normally, right?
Yeah.
But so do we need to have a necessarily large sample, or we can assume that any model, like, the CDF would be normal? Because
It's
Like that's not necessary,
yeah,
right?
these maximum likelihood estimators always assume that you have a large sample,
Okay.
right? Because
So,
at some point you need to use the central limit theorem for them.
okay.
Okay.
So like above 100 and something would be considered large.
Well, there's a whole literature on how big is big.
Yeah.
um,
Yeah.
but we assume it's a large sample. I'm assuming that the 56,000 that I've given you, or 53,000,
That's pretty
whatever,
large.
that's probably big enough.
Yeah.
Yeah.
Yeah. Okay. Thanks.
Yep. All right, anybody else? All right. Well, I'm gonna feed my lawn. And then I'll be back. So I will plan to be here on Friday, and I'll take any questions you have on Friday. And then next week we'll talk about those other models. What are they called? Whatever kind of models they are. What are they? They're treatment effect models. There you go. I knew reaction function was the wrong term. All right. Stay safe. I'll see you Friday. Okay.
Thank you.
Bye.
Bye.
You.
Bye.